Alright, so
Toilet paper.
how much salt can you put in water and have it dissolve?
A teaspoon.
Probably a lot.
How much salt you put?
How much sugar can you put in a glass of tea?
Depends, is it hot or cold?
Ah, it depends on temperature. What else does it depend on?
How much of water?
Yeah, how full the glass is?
There you go. So y'all have some intuition about solubility already.
Because of white Jesus.
So, a concentrated solution has a large amount of solute.
And solute is
What's being
solute.
dissolved.
And dilute solution is whenever you like.
Whenever you have a small amount of solute.
I thought you dilute something by
By increasing the solvent.
So, like, that would be, say you always have a glass of water. Then
So, if you have...
Like, with the concentrated solution, would that be, like, a lot of sugar versus the dilute solution, which is not much sugar?
So, if you're putting sugar into water, you're, to make a solution, your solution will be the sugar plus the water. The solvent is what's dissolving it. It's the water. And your solute would be the sugar. So the large amount of it is sugar. I mean, the large amount is water. So this is your solvent. It does the dissolving. And this is your solute, wherever you're putting in it. So if you want to dilute your sugar water, you can either add more solvent or reduce your solute. So if you want to dilute your sugar water,
you just add more water.
You can increase the solvent, which is your water, or reduce the amount of solute, which is your sugar.
How do you reduce something like this all?
By not putting it as much into it to begin with. By throwing it away and getting another glass of water and putting less sugar in it. You can. How can you separate the sugar from the water?
Evaporating it?
Yes, you can do that. Alright, so you are kind of correct in this in this context. It kind of means removing the sugar, but it's more of, do you want to make a if you want to make a diluter sugar water mixture? Be a better way of wording it.
So just the opposite of that, would it be concentrated?
So if you want to make a concentrated solution, yes, it'd be the opposite. Use less water or more sugar.
But would it be the concentrate versus that? Like the two diverse?
Yeah, they're opposites. Any of y'all buy juice concentrate?
Like, that's just straight juice, right? That's just straight.
What are you doing, Cody?
I hate these boots.
So you take a walking class?
No,
It's
it's
like
like
hurt
my
my
feet.
Huh?
Freaking burn.
So there are some juice concentrations as a small can, and you put it in a gallon of water, and it makes a gallon of juice.
Like in some drinks they'll have like concentrated apple juice or concentrated
Mhm.
grape juice.
In which case, you should definitely dilute it, not drink it as it is.
Yes.
Wow.
What if you just drink it straight?
And it won't do anything, but you're wasting it.
Wait, straight apple juice?
Concentrated apple juice.
You can buy concentrated apple juice, concentrated any juice, and it's supposed to make you about like a gallon or wherever, however much concentrated you do of juice, and you can drink it by itself, but that's very wasteful.
How's it wasteful?
And they'll probably drink for them.
That would be like taking a 12-pack of Coke or a liter of Coke and drying out all the water to where you have only a teaspoon of powder left and eating the powder. How would you do that? It's wasteful.
It's like dehydrated
so
water.
concentrated.
Buy
So there's multiple different ways of measuring concentration. Concentration by volume or concentration by mass/weight. Sometimes you'll see it written as concentration by mass or weight. Technically, as long as you're not going from Earth to the moon, concentration by weight is the same thing as concentration by mass. So these are, in chemistry, these are two different ways of doing it, and it's very different. Very important you know what your concentration is using. For example, let's see if I can do this.
Or like a 60
Um,
milliliter, or 60 ounce can. That's 32% juice.
let's suppose I have a 1 millimeter cube of lead. And that would weigh 11.35 grams for 1 milliliter. And then I have water, 1 gram for 1 milliliter. So, because of the densities of these two, if I combine these together, what percentage of lead do I have? If I do percent by volume, it's obviously a 50-50%. I have 50% lead by volume and 50% water by volume. Right? Because I have 1 milliliter and 1 milliliter. If I do by percent mass, then I have a total of 12.35 grams. So to figure out the ratio by mass, I just do 11.35 divided by 12.35.
I have a question.
Yes.
Okay, so you know how air weighs some? Like, so
Mhm.
like if you fill up okay. So if I exhale all the air out of my lungs right now, would I weigh less?
Yeah, just like if you remove the single hair from your body, you weigh less.
I'm gonna like say exhale and then like I'm gonna like how
Guys, cool it.
how much
Guys, pull it. That's irrelevant. So if you do it by mass, you would have almost 92% lead and 8.1% water.
So how did they make the percent water that we have?
It depends. Again, it depends on where you look up. Are you asking for percent volume or percent mass?
I mean, when they say
Again, it depends. They measure it in two different ways. If you just Google what percentage of water you are, you have to figure out whether or not the percentage given is percent volume or percent mass. If you just look for a random number and you do not confirm whether it was percent mass or percent volume, that number means nothing. You have to make sure what you are, what type of percentage it is. So if you Google what percent water is in the human body, and then it usually doesn't give it. Let's do by mass. It's very difficult because you find a lot of places that aren't very scientific that doesn't clarify, and then you can't use their numbers. So if you look up random things, you'll see the word 90% of their body weight comes from water.
Of ours?
This is for most organisms.
So I'm
For
not
humans, it's up to 60%.
So much water weight. I'm not fat. Okay. Show science.
All your cells are made up of water. Your fat cells, your muscle cells, even your bones have water in them.
Oh, yeah. So I'm basically.
No, your bones too. Your bones are alive.
So I'm
They're made of
basically-
cells. Brain is composed. So at the very beginning, it says by weight. So by mass.
That's cool. Then I'm 60% water. So it's water. Question more question.
So we can have an unsaturated solution. This means it's capable of having more solute dissolve in it. So this is so if something is unsaturated, you can put more solute in it. So if you had an unsaturated sugar water mixture, you can put more sugar in it and have the sugar dissolve. Now, if you keep adding sugar, what's going to eventually happen? And Thomas, stay awake. Remove your hand from your head. Your sugar will stop dissolving. This is known as a saturated solution.
So, like, if you eat so much sugar, eventually it'll stop dissolving in your body.
Quit talking, Michael.
You're a big problem. Keep it out of your little face.
So, is there any way to possibly get it more to dissolve?
Add more water.
Adding more water? What if I only have 100 milliliters of water? I'm stuck at 100 milliliters. I cannot increase or change the amount of water. Heat it up. And what happens if I cool it down?
It's not freezing.
No.
I did.
I mean, it does talk.
Would it be dissolved?
Yes,
It would undissolve. I'm gonna guess it.
There are ways of making supersaturated solutions. They're unstable. They do not. So how you make an unsaturated solution is you heat it up and allow it to cool off fairly slowly.
I'm not gonna do this.
It's almost, has anyone ever seen super cooled water? Where you put it in a freezer, it has to be pure water, and then you remove it from the freezer, you hit it, and it instantly freezes?
Then you drink it and it kills you.
Quit saying nonsense.
Yes.
So usually what happens is when you lower the temperature, it'll fall out of solution and no longer be dissolved. But there are ways it's unstable, meaning it doesn't usually stay dissolved. But there are ways of making it stay dissolved. Yes.
So with the water bottle, when you said you hit it, if it's below the freezing point, in order to freeze it, freeze by itself without hitting it.
So it needs a nucleation site.
I mean,
It needs a starting crystal in order for it to become ice. Water doesn't naturally become ice unless you have a starting crystal, some sort of seed for that water ice to actually grow off of. And if you have a very smooth plastic bottle, pure water, or pure enough water, crystals can't grow until about negative 40 degrees Celsius, way below freezing. which means you can, as long as you don't create any disturbances in it, have supercooled water that stays liquid. Likewise, if you heat something up to a high temperature and allow it to slowly dissolve, or slowly cool off, then the sugar or something will stay in it. Interesting. Have you ever made rock candy?
Like with you get sugar and water and the thing, and you let the stick in the
Mhm.
little cup.
So, if you have a super saturated solution and introduce a single crystal on it, immediately any precipitate will immediately start growing off that crystal. It's unstable because what happens is in order for it to fall out of solution, it needs a nucleation site, meaning it needs some point in which crystals can grow, and for it to fall out. And usually this happens by you shake it, an air bubble comes up, or some mechanism, some scratch on the surface, and it forms. So let's look at how to actually measure solubility. Solubility is defined as the maximum amount of grams of solute that can be dissolved in 100 grams of solvent at a given temperature. It is important to remember that 100 grams is equal to 100 milliliters of water. For water, grams and milliliters are the same thing almost, because the density of water is 1 gram for every 1 milliliter, or 1 milliliter of water weighs 1 gram. But solubility varies with temperature and is based on a saturated solution. So solubility basically tells you how much you can dissolve for every 100 grams of solvent, or for every 100 milliliters of water, or 100 grams of water. And we'll assume we'll only be working with water. The two major solvents are alcohol, meaning ethanol, and water. But we'll be sticking with water. So this is what we're mostly going to be doing, is looking at the curves like this. It shows the dependence of solubility on temperature. So, let's look at something we're used to. NaCl. Does anyone know what NaCl is? Salt is ordinary table salt. So, at freezing, about 35-36 grams of salt will dissolve for every 100 grams of water. So, anything past this, it will not dissolve and it'll be saturated. If I were to crank it up to near boiling point, it doesn't really change that much. It's now about 39 grams of salt will dissolve in it. So salt concentration doesn't really change too much with temperature. I'm trying to think of... Let me look up sugar.
Sugar is created by iron and chlorine.
Stop saying nonsense.
What does that make though?
Again, stop saying nonsense and talking about stuff unrelated. So sugar, solubility.
Mr. West.
Yes.
So I've heard before that hot water freezes faster than cold water.
You'd have to look at it. It's very... It's... There's been a lot of study on it. So, sugar is a very big molecule. It's like 22 carbon, 10 hydrogen, and 20 oxygen or something. I'll look it up.
Sure.
Table sugar is sucrose. Sucrose is... I don't know what sugar this is. Sucrose formula. It's carbon 12, H22, oxygen 11. What was your question?
Also, it's not C6H12O6.
That's glucose.
Oh, it's just glucose.
Glucose is blood sugar. Table sugar is this.
That's not much.
And this is probably glucose. But you can see here 175 grams per every 100 grams of water at freezing. But sugar is heavily dependent on temperature. If you go from 0 degrees Celsius to, and what's 175 times 2, because I'm lazy, 350. So if you go from 0 degrees Celsius to 75 degrees Celsius, you can almost get twice as much salt to dissolve. Yes. Or sugar. Whereas salt doesn't really change that much. So looking at this graph, if I'm right here, so here's the solubility line. This base, if I'm right here, I would be unsaturated. Or what's the correct term? Yeah, unsaturated. I can still dissolve more sugar. If I am on the line, that means I am saturated. And if I'm above the line, that means I'm supersaturated. Now then, let's say that this line right here let's say it's 250 grams. What would happen if I have 100 grams of water and I put in 200 grams at this temperature right here? It would be unsaturated. Because right here it tells me that at this temperature T, wherever the temperature is, it can store 250 grams. So if I'm less than 250 grams, I'm unsaturated. Now then, what would happen if I put in 250 grams? It would be saturated. What would happen if I put in 300 grams of sugar into 100 grams when the solubility is 250 grams per 100 grams of water? So what would it be then? What would 300 grams do? So I'm putting in a block that has 300 grams into the water. And what would happen? 200 grams will be dissolved. 250 grams will be dissolved, while 50 grams will sink to the bottom. As precipitate. Lift your head up. Yes. This would still be saturated. And it will still be on this line. That's an important distinction. Just because you add more sugar doesn't make it supersaturated. It doesn't actually get it above this line. Once you reach saturation, any more sugar added will not dissolve. To make it supersaturated, you must heat up, heat the solution up, and slowly cool it off. It has to be slowly. Everyone good? So does everyone understand the fact that if I put 300 grams when the most that can dissolve is 250, it would not be saturated? I mean super saturated? Because 50 grams would sink to the bottom.
It's like getting a container of salt and setting a drop of water.
So look at this graph. We see a lot of them go down, or a lot of them go up. But we see some of these dash ones. What do you think these dash ones are?
Decreasing.
Gases. They are decreasing. So most salts, when we increase temperature, we get more to dissolve. However, it's the opposite for gases. For example, CO2. How do you get more CO2 to stay dissolved in your drink? You keep it cold. If it's too hot outside in your car, especially if it's upping, it will go flat very, very fast. It's also pressure. Pressure helps too. In order to get CO2 to dissolve, this bottle is under pressure. So solubles are more soluble. Solids are more soluble at high temperatures. Gases are more soluble at low temperatures and high pressures. So if you increase the temperature, you can get more sugar and salt to dissolve, but the amount of oxygen and CO2 will decrease. To get more gas to dissolve, you need to lower the temperature and increase the pressure. Make sense?